here we work, or we are close to the buildings and construction sector. We know that half of what will be standing in only 30 years has to be built. And any climate action, we hear this all the time, must be built on solid foundations. Science must provide the solid foundation on any climate action. And this includes buildings. So that half of the built environment to be built yet by 2050 must be built on the strong and wide shoulders of the science. And we have here a representative from Yale. And Anna Dyson is going to introduce us to the findings of a recent study, Building Materials and Climate, Status and Solutions. Anna, please.
Should I advance here? Okay. Thank you so much for coming. I'm extremely honored to represent our team here. We have a large team that spans 6 continents, looking at the challenge of building materials in the climate. I'm represented here today with my colleagues who are co-leading the study. Dr. Mae-ling Lokko from Ghana is leading the West African spotlight. Dr. Mohamed Etman, who will be joining our panel today, is co-leading the India study. And Dr. Naomi Keena is leading the North and South America Circular Material Economy study. So we're a large group of architects, engineers, scientists, and industry professionals who are looking at how we can really rethink building materials and the climate based on a wealth of practices that we've accumulated over thousands of years. And it's true that our approach and our report will focus a lot on the science. But I think it's really important also to say that building materials are not just about so-called embodied energy, that is all of the energy that we expend to extract, produce, transport, and implement building materials on site, or about the operational energy or carbon, if you will, if it's a fossil-based energy that is used to drive building systems for heating, cooling, lighting, and other plug loads. But it's also about the impact that our material use has on regional ecosystems and on urban heat island effects and other ancillary costs of materials, the way that we metabolize materials globally and locally has extended impacts on global health of living systems, including and especially human systems. So we're going to be looking at this from the standpoint of a whole building life cycle. But first, let's look at how and where we're using materials today. Today, as we can see from this chart, the preponderance of our building materials are coming from extracted mineral-based materials, concrete, steel, brick, and aluminum. And they constitute the vast majority of the carbon footprint of the global building sector as a whole. However, and we can see here in 2015, it's tempting to think that this is how we always have to build and how we always have built. But if we look at this chart from 1945, this is post-World War II, we can see that the preponderance of our global material flows were actually bio-based. We had a small fraction. We managed to build very large global cities with bio-based and earth-based material processes. And how did we do that? Across the world, the preponderance of the materials, as our illustrious panel from this morning pointed out, came from local sources of earth and bio-based materials. And we can see that they were very much adapted to local bioclimates. We can see here we have a hybrid hot, humid, hot, arid climate on the right, and on the left we have a hot, humid climate. We can see they're not the same shapes, they're not the same forms, and they're not the same materials. Here we can see on the right-hand side how materials were formed in order to actually respond, even within one day, a change in wind patterns and slight changes in humidity. Tremendous knowledge, embodied knowledge, let's say, that we had for centuries that we have largely forgotten about in the 20th century in our so-called advanced systems, our scientific or advanced engineering systems. And we're not advocating necessarily a back to the future. We're not saying, let's go back to the way we built 100 years ago, because we know that with the global population and market pressures, we need advanced materials and we need scientific-based advanced processes. However, we must combine with going back to the fact that we need to tailor our materials if we're going to get to so-called on-site net zero energy, or let's say net zero energy and water, because we always have to look at the energy-water nexus in our material production, extraction, and maintenance, then we really do need to start to look at a tailored on-site local solution to our buildings. And we do need to start to shift back towards bio-based and biocompatible processes as much as we can, while maintaining the health of regional and global ecosystems and forests and agricultural lands. So just looking at what we do with energy and, let's say, the carbon footprint, what we're looking at, if we are largely a fossil-based energy economy, which unfortunately we still are, but we are going to shift towards renewables, we look at the embodied carbon of materials, and we look at operational carbon emissions. This is really the material carbon emissions will have, as we said, all of the process-based emissions. And then ultimately, it leads towards what we call a carbon use intensity, which we can measure in our buildings over time and over the course of a life cycle. This is a chart to illustrate what Jonathan was talking about, which is that as we start to decarbonize our grid over time, as we get better numbers in terms of the way that we are operating, and as we get better practices for operational energy, that is, we're going to decarbonize as much as we can our heating, cooling, lighting, and plug load systems. We can see here that in the light green, the embodied carbon of materials starts to take on greater and greater significance proportionally to the building life cycle over time. This chart shows in the light blue operational carbon with a standard performance building, but in the dark blue we can see that we are largely starting to decarbonize. As our prior speakers have said, we have some good news on the operational front. But let's take a look at materials. And I apologize, this is a little bit washed out, this slide, but we can see, if we were going to go all the way to the top of this chart, that primary concrete is the preponderance of the bulk of the building materials that we use. We can see that only a fraction of that is recycled, less than 10%. When we look at the metals, like steel and aluminum, of course we know that they can recycle very nicely, but what is the proportion? It's very small still. Why? Because we have a growing gap between the demand and the supply of recycled aluminum and steel. So we don't have as good a story as people will tell you. We need to do better in our design for disassembly and reassembly of these systems. Now if we start going towards the bottom of the chart, and on the left-hand side you see 2020, where we are today, we have a tiny fraction of materials that we use in the bio categories, even timber. Timber, you would think that would be much larger, as I showed you from our graph from 1945. It was the preponderance of material flows were bio-based. Today it's very small, but we could, if we were to sustainably manage wood, timber, bamboo, agricultural waste, mycelium, and living biomass, they should, by 2060, really rise to be about half of our material sector. then the preponderance of our non-renewable sectors need to start to participate in what we would call a circular material economy. That means that we need to try as hard as we can throughout the life cycle to design out the waste, meaning we're going to design for reuse of materials, and then if we cannot reuse, we will recycle. Of course, as we can see on this chart, everything that is not, we're still going to be using a lot of materials, a lot of primary-based materials in 2060. We're still going to be producing, so we have to figure out how to decarbonize the production and the gestation of materials. Now, how do we do that? We're looking at really exemplifying within the built environment sector exactly what the Secretary General told us at the beginning of this conference, that if we do not cooperate, we will not reach our goals. Nothing could be more true about that statement than the built environment sector, where we must look at the production, construction, use, and end of life, or we would say end of use, because we don't want to take them out of their life cycle. And through research, policy, and finance, we must simultaneously incentivize the stakeholders across that life cycle to cooperate and to be equally responsible. We need a level playing field. We have to close the carbon loophole in the built environment sector. We cannot penalize countries that are producing and under a tremendous amount of pressure to produce at a very, very low cost. We must be shouldering the responsibility. We cannot have either a taxation for reducing costs and reducing environmental regulations, and that also includes human beings in the process. If we're going to have sustainable ecologies, human beings are the living systems within those ecologies, so we must also couple fair labor practices with fair environmental practices and support those countries in order to get fair prices for those practices. So, as Jonathan said, we are looking at a framework to look at avoiding, shifting, improving, and adapting the built environment sector for materials. And when we say avoid, we're saying design better with less. We're not saying do without. This is a very, very important distinction. A lot of people, when they hear saying build less or build with less, we're not actually saying that, because I don't think that it's in any way viable or fair to emerging economies to say you should stop building after many advanced economies have built up. What we're saying is build better, decarbonize, and we can then the global south and emerging economies will show the rest of the world the way, and they can leapfrog in many sectors, as we'll see in a minute. We're going to shift to the use of alternative materials. We have to improve our decarbonization of conventional materials, and of course, adapt to reduce operational carbon in general. One of the most important aspects of our report that we're going to focus on is it's very difficult, actually, to transition from a linear to a circular material economy in construction. There's a lot of lip service that's given to it, but it is not an easy thing, and that's why we need the cooperation. We need to basically look at how energy, water, and primary materials will, instead of being the primary producers in the built environment sector, because it's by far the largest sector towards emissions, wastewater, and construction waste, we're looking at keeping those secondary materials in the system, and also even with on-site zero and district zero sustainable means, keeping energy and water into the system through renewable means. One important thing that I also think we need to focus on here is that the more we build, the more materials we have in the built environment sector. So we have a lot of those materials, especially in the global north and in evolved economies that have really a lot of mid-20th century failing structures that they could be recuperating and reusing. We can start thinking about materials, buildings not for demolition and landfill, but as material banks. But one very important thing about that is, at end of use, we need to very much prioritize the adaptive reuse of buildings themselves. That means our first, all of our first choices are on the right-hand side of this graph, meaning that we want to reuse our buildings. If we can't reuse our buildings, we'll reuse the components. If we cannot reuse the components, then we will reuse the materials, and as a last resort, we will recycle. So recycling is a buzz term, but that would be our last resort in a circular material economy. Why? Because it's very chemically and energetically expensive. So we don't necessarily want to do that. We want to keep things in place if we can. How do we keep things in place? All the way back to the design phase. We have to design for disassembly and reassembly and reuse as much as possible. So a quick snapshot, and then I'll pass the baton to my colleagues. In the different sectors, cement in the concrete sector is by far the contributor towards the carbon footprint of the concrete and cement sector. But as we know, concrete is extremely valuable to us. It's durable. It gives a great amount of structure for the price point, and it's not going away. So we need to reinvent cement, and it can be reinvented through a number of different strategies. We have to avoid the material overuse by optimizing design. That means digitalizing the process as much as possible through computer-aided processes. We'll adapt carbon capture and storage at plant, but also potentially inserting that carbon back into the production of concrete itself in order to increase the strength of concrete. And of course, as I said, we want to adapt with as much bio-based content and of secondary materials as possible. Steel is the next largest emitter, carbon emitter in the built environment. And with steel, really we need to improve the quality and collection of scrap, because steel can be very nicely recycled or reused, components reused. This is a good example, this building we're in right now, of lots of recycled aluminum and steel, or reused, that we can design for disassembly and reassembly very quickly in all of our buildings. We need to shift the production to renewable electric energy. That means we need to electrify the process and use best available technologies. We need to adapt the design of materials with the entire building life cycle in mind. Aluminum is a growing area. We use aluminum. We're increasingly replacing steel with aluminum on building curtain walls and facades. We need to dramatically improve the recycling rate per the initial chart that still shows only a fraction of recycled aluminum, because we need to adapt the design of alloys with aluminum alloys with recycling in mind. And we really need to shift production again to renewable electric energy sources. All of these materials, concrete, steel, and aluminum, really depend on a clean grid mix. We will not decarbonize without the grid. In fossil-based plastics and polymer composites, this is also a dramatically growing area. We can see it all around us. There's probably not one single surface in this building right now that doesn't have a plastic surface on it, and we can smell it. So this is a big issue for health and well-being. We need to dramatically reduce and shift the off-gassing of emissions in the production of plastics and also in the implementation. I feel obligated to say that as we sit here. We might have a few headaches in the room by the end of the day. But we also need to adapt towards greater and greater bio-based feedstocks. We're not quite there. We need to improve collection and sorting, but with bio-based plastics, like with all the material sectors, we really need to improve the research and development towards the circular adoption of aquaculture waste and also agricultural waste towards bioplastics. So we can partner with the agricultural industries in this way. Glass is a very, very important material for the future. It definitely gets a hugely bad rap, a deserved bad rap around the world, because we've replaced, in many areas, commercial building stock from sustainable, local, earthen and biomaterials towards a lot of glass and steel on the facade. So glass has, in many areas, especially in those cooling degree climates like the one we're in here in Egypt, it has dramatically driven up the cooling requirements and loads of buildings. However, and this is a big however, glass is very important towards future on-site net zero, because it may be the material that we need in order to maximally absorb, capture, store, and redistribute solar energy for internal building loads. So we need glass, but we need to adapt glass not to reflect energy and waste the energy, but to take it into the system. So we need to very much shift towards the electrification and shifting to best available technologies, improve incentives for local production and recycling. Very important in glass. We can recycle. It's one of the best materials for recycling. But we also need to adapt renovation and demolition practices to maintain the quality. It's fragile. Easily, curtain wall systems and glass systems can be destroyed in that process, and we need to both design for demolition in mind so that it can be reused. And finally, oh my goodness, sorry. Oh, my. Okay. Finally, we need to ramp back up. This is the back to the future moment. We need to go back also to abundant earth materials like masonry and earth-based. We need to adapt standards for earth-based materials. In Africa, we have some of the most beautiful global heritage architecture that is earth-based. And we must learn from the past to go back to these very sustainable methods where they are biodegradable and they can be a great part of the circular material economy. But we need the standards because they're not regular. If the more material you have in earth and material, it can be very much dependent on the local geology and earth conditions. So standards are critical, but we can improve in so many different ways. We also need to shift social material acceptance. Sadly, there's a premium on so-called modern buildings around the globe to show that we're modern. And so a lot of times in regional economies that have a wonderful tradition of earthen-based materials, it gets rejected because it's not the image that a lot of companies maybe or buildings want to project. So that is a challenge that we have. It's also a challenge with timber and wood. We need to shift the social acceptance towards understanding that this is a material that can last a very long time. Actually, where we're from at Yale, the preponderance of the building stock is in wood, and it's lasted for 4 or 5 centuries. We have many old houses that are already more than 400 years old, but they're maintained over time, so they stay in place. We have to improve the material recovery of timber-based, and we very much, per what we're smelling today again, we need to avoid petrochemical-based glues, chemicals, and coatings that are terrible for health and well-being, terrible for the ecosystem, and also reduce the circularity of these systems, our ability to recycle them into new material economies. This is just a quick summary snapshot. If you see the business as usual, even if we adopted all of our best practices and all of our, the things that are happening right now with the decarbonization of materials, we will still substantially increase in the carbon emissions by 2060 if we're business as usual. So if we adopt all of the different whole building life cycle from production to design, distribution, and implementation and end of life, we can dramatically decarbonize all of these sectors. But we must shift over towards the bio-based. And I know that I'm out of time, I didn't want to. And lastly, I just want to emphasize that we need to also go back to designing through nature-based processes. We need to start thinking about biomass materials as a material. That means living systems are materials that we will design our cities with and we will cover surfaces with. And we will be part, once again, of the kind of bio-based pathway as opposed to the mineral-based pathway, which, as we see, is only part of our recent history. Only the last 100 years did we start really ramping up on mineral-based processes. The preponderance of human history and civilization has been compatible with bio-based processes. Thank you.
Well, thank you very much. I have the feeling I am stepping out of a master at the Yale Center for Ecosystem in Architecture. Thank you so much, Anna, for what you do. Thank you for distilling so much work, and congratulations to the professors who are probably watching us online and who also contributed to this study, which is really an in-depth X-ray of the current situation of how do we build our buildings and what we must change.